Not very convinced about how accurate this VU meter is going to be now with the new head, so I thought the first thing to determine is where I appear to be clipping. So I've arranged a 1 kilohertz tone to go in it, and I'm going to try 80, 90, 100%, edge of the red, middle of the red, top of the red, and then rewind it and have a good listen to the tone to see if I can actually hear the distortion. I expect the other way to do it is put it on the spectrum analyzer and analyse it for harmonics. So that's what I'm going to do now. So I'm going to sort of start at 80% and then I'll blank it and turn it up to 90%. I think I'll go that method, I think, and then I can replay it and just see if we can actually hear the distortion. I think it'll be fairly obvious when we hit the distortion point. At some point, once I've more or less determined that, I'm going to have to work out where the VU meter needs to, if it needs to be twigged. There is a control for that. But yeah, so that's 80, so I'm going to pause it and bring it up to 90. I notice there's a little variation in the meter, which is a bit odd. Let's put a bit of silence in. There we go, and then I can tell the breaks between it. So I'm now going to just let that record a little bit more and just creep my way up through the recording level and then play it back and see how we get on. Go for 100% now. That's 100%. I'll just keep creeping my way up. Well, I'm now making my final recording. As you can see, the meter is now nicely pegged. I've noticed a little bit of movement in the needle still. I'm not sure why that is. I'm going to have to investigate that. Everything's been cleaned, so there shouldn't be, but I guess once I've finished making this test recording, I'll rewind it and have a listen to see if I can actually hear the distortion. Just found another little problem. That channel's working, that one isn't, so obviously something has fallen off again, I reckon, probably on that DIN lead. So one channel is not recording. I've got playback but not record, so it's another problem to deal with. Having a little play with this, I've discovered that the secondary DIN socket, I can't remember if it's the in-out or the record playback one. I've noticed that's slightly out of balance, but this one looks fairly even on the left and the right, so I'll use this one. There must be something wrong with the other DIN lead that I had, so I'll have to see what's wrong with that. So now I should be able to, oh yes, you can see it being additive there. Got both channels in. It's interesting. Let's turn that down to 50%. And how much does it go up if I add the second channel to 100%? Oh, that's interesting. So it is biased 50% each channel. Well, that's interesting to know. Okay, well now I've got both channels working, I'm going to do my test recording yet again and just see what we get. In the finish, what I'm deciding to do at the moment is use the dB meter to see if I can see a compression point. I don't know why I didn't think of that before. That seems to be the obvious approach to it, but because I'm having difficulty detecting distortion, there's also quite a lot of woe and flutter. I'm going to have to look at that again. Perhaps I'll try a different tape. Well, the other obvious answer, and there's a 3 dB difference between the channels, so I'm going to have to look at that, is to use the old Kenwood, assuming that's calibrated, and I bet it is, being an auto bias machine, is C, that'd be the third one, That's sitting at 0. I'll use the highest channel and watch it go up. But of course I've got evidence there that as we're getting towards the middle red, it is getting to the red, it is beginning to compress. So you know, it's definitely sort of happening there. You know, you can see the compression in the red. I was thinking, before I start getting into the realms of adjusting the bias, checking the recording, adjusting the bias, I think a natural thing to do would be just to do a frequency response test first, again probably 1 to 12 kilohertz, and see what we get. Conclusion from listening and what the Kenwood's saying is you're probably not saturating until you hit about the middle of the red. Any higher than that, and I can definitely hear the distortion, so I think I'll leave it at that. I'm now going to do some tone tests, and then we'll see how flat it is using its own record head this time. Okay, so looking what we had before, using the tape from recorded in the auto bias machine, that's what we had before. This is what I've got now. I think I've got too much bias. I suspected that before, so what I might do is just turn the bias down a little bit, and we'll just run the test again and just see if we can improve on that. Okay, I've got some test points on now, and I'm now looking at those 39 ohm resistors in the bottom of the heads. That's the bias signal you can see, and if I put some modulation in, you can see it modulating it. That's 10 kilohertz. So I'm just going to work out what I'm putting in there. I've decided to use the analog scope because the digital scope's just too noisy at low input levels. I'll need to convert that back into RMS, I guess, but I'll do that in a moment. And what I'll do is I'll make a note of what the bias is, and then we'll look at how big the 10 kilohertz signal is when I play it back, and that might give me an idea of whereabouts to set the bias approximately. Alternatively, I could just keep adjusting the bias and looking at the frequency response I get. But it is quite a tricky thing to do. It's much easier when you've got 3 heads, but I haven't got that luxury. But I don't want to turn the bias down so far and then increase the distortion. But yeah, we'll see. Right. Well, I've had a first go at changing the bias. It's now 16 millivolts RMS instead of 22. I've tried 2 different tapes. Yeah, there's an improvement for high frequency end, most definitely, reducing it down to that level. But it's just not as good as the playback when we had the recording on the done on the Kenwood. So it's a little disappointing because that looks pretty good, unless I've made some error in this, but I don't think I have. So it's suggesting that the record still isn't that good. It might be the head I've got. It might not be particularly good at record, it might be better at playback, I'm thinking. But I think what I might do is have a look at the signal on the head. But that's a little disappointing how it falls right off over 8 kilohertz. That's really quite big. That's suggesting that this recorder was good to 10 kilohertz. So yeah, a little disappointing that, but let's do some more tests. I'm just looking at the bias current again. I ought to stop the bias oscillator for this test, but it's going to take me a little while to find it, so for quickness I'm just going to whack up the frequency and just see 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's a little bit of emphasis there, not a lot. That's not where I'd expect to see the emphasis anyway, it's more at the lower end I'd expect to see emphasis. So yeah, that's 10, 11. I was just wondering if the electronics is blocking the higher frequencies. 14, 15, 16. Yeah, it is once you get above about 15. Okay, so you can see the audio there. So That's fair enough. I'm going to try going a bit lower now. 900 hertz. That's 500 hertz. I'm struggling to trigger this because of the bias signal being superimposed, but 500. I would expect to see some pre-emphasis now. I'm quite puzzled. 400, 300, right down now. It's probably going to flicker like mad on the camera, but now I honestly thought that there would be more emphasis than that. I am puzzled. I'm very tempted to turn the bias down a little bit more, but I'm concerned if I turn it down too far I'm going to enter the non-linear region, so okay, something to puzzle about. Well, I managed to stop the bias circuit. Trigger. I managed to stop the bias circuit simply by loading up its output where it goes to the heads, because it uses the arrays head in series with a capacitor in the base circuit. So by simply putting a little bit of load on the base circuit so the feedback stopped, I've now stopped the oscillator dead. It's good, so I didn't have to replace the raised head, isn't it? Right, that's 100 hertz. I'm going to go up. Ooh, it is rising considerably. Wow. Yes. Now, another point is, previously I was looking at the current, so let's open that up. Oh yeah, that's rising very nicely. That's 3. Oh yeah, look at that. Good grief. I'm actually looking at the head now, voltage wise. Ooh, that's interesting. Yeah, that's definitely interesting. That doesn't look very nice, does it? Ooh, that's interesting. Now, is that because it's looking at a higher load because I've loaded and stopped the oscillator, or is that... Ooh, no, that's not nice at all, is it? 10 kilohertz. Right. Oh, that's interesting. That's interesting to note. Right, there we go. Oh, definitely. Oh, I can see the pre-emphasis looking at the voltage. Oh, not too far there, I think. Okay, let's have a look at the current. I'll just pick current going into the head. Actually, that makes sense if I think about it. What we were looking at before. That's very noisy. Okay, go up again. Yeah, the current's almost constant, isn't it? It would be. It's an inductor. That's where I was going wrong before. I thought, well, why is there no pre-emphasis? That's because I was looking at the current flowing into the head. Of course, that no relation to voltage as well. Well, that's answered a few questions. So there's no good me trying to look at the... Yeah. Oh, well, there's definitely pre-emphasis there. No doubt about it. When we look at the voltage reading, quite a lot of pre-emphasis. Turn it down. Go up again. I do not like that clipping. Grief. Get the right position, it would help. Oh yeah, that's a lot of... Wow. That's a lot of pre-emphasis. Let's have a look. Is it clipping again? Ooh. That's not nice at all. And that's 40% modulation. So it's starting to clip. Every time I look at this tape recorder I seem to find something else I'm not happy with. Oh dear. Okay. Could well be that it could be the loading. But that's a little bit worrying, that. Why is it clipping? Why is the head drive clipping? Yeah. Hold this scope probe on. I'm just looking at the driver stage for the head. That's looking a bit. That's clipping at the top as well. This affects both channels, so I've checked. And the scope probe loses contact, so I want to demonstrate it, but never mind. But yeah, it's clipping at the top, definitely. We're only just in the red. That's surprising. A little shocked about that. Here's the driver. It's already clipped. Ooh. Okay. Yeah, it's just on 100% modulation. That's clipping. Oh, could explain a lot. Would explain why the high frequency is not very good on record. I don't have an explanation for this. One possible explanation might be a supply voltage issue, that the supply voltage is wrong, but I'm pretty certain I tested these when we started this project. Ew. Well, I did say I only wanted to use it for playback, so maybe that's the way it's going to be. Right. I'm still looking at this clipping issue. I've checked the supply voltages, good. Transistor voltages, good. So I think my conclusion is that it might be worth me doing this frequency response test with a lower recording level. Yeah, look at that. Brick walling totally. And the supplies are good. I'm at 9.2 kilohertz. Well, at least it explains why I'm not seeing such a good frequency response as the tape that was recording on the Kenwood. So, question is, do I try and do something about it? I think the answer is no, as I want to use this as a display deck really for playing back of tapes. I think I'll leave it there for now, because I've been working on this project for some while and I have a lot of other projects I'd like to work on, so I'll just accept it as it is. Just when you think you've got everything, another little problem occurs. Will it focus? Yeah, one of the channels kept going funny, and I discovered it kept banging the board, and wasn't a dry joint, it was actually the cap of the resistor. It's come off. That was a lucky find actually, because that would have been quite annoying if I got it back together and it started playing up. But yes, it's obvious that these caps can fall off. So there we go. Anyway, so that's another problem solved. Thanks for watching my series of videos on the Dynatron CP1. It's not been a totally successful repair. Still issues with the record and the motor isn't fantastic, but given there's been so many problems with this deck, the only thing I haven't changed is any capacitors. That's an interesting thing to note. But obviously the problem with the pinch wheel as well, the head, I should have noticed that before I even started this project, that the head was a little bit on the rough side. So anyway, I hope you enjoyed watching this series of videos, and perhaps I think I'll work on something that isn't a tape recorder next, because I think I'm a little fed up with tape recorders after this one. Anyway, thanks for watching once again.